right, this is your activity 35 and 34 review. Again, just going to hit at least one type of each, or at least one problem of each type, I should say. Going to pull up the pictures from the online version of your book to look at a couple of these here. So the first four are all the same type of question where you're looking at the picture, determining if the function is periodic, and then if it is, determining the period and the amplitude. So looking at this, if I look at number one, it says, first of all, we had to decide if it was periodic, which this one obviously is. It looks like a reflected tangent graph, but you know that it's periodic because all the exact values, you can see the same inflection point. They repeat at regular intervals. So that's definitely a periodic function. The period, remember, is the horizontal length of one full cycle. So you have to be careful with this one. And if you look at my answer on the answer sheet, it says 2 pi over 3, and then it says or 5 pi over 8, or anything bigger than pi over 2 but less than 3 pi over 4. Let me explain why that is the answer. Because remember, we're looking for the horizontal length of a full cycle. So if you look, this line crosses just over this axis. So the asymptote is somewhere between this mark at negative pi over 4 and the y-axis. And also, even if this were at 0, if you look over, the period is not pi over 2 because this part of the tangent graph crosses that pi over 2 line. So that doesn't work. You know it can't be 3 pi over 4 because this is crossed. So the asymptote is somewhere in between this mark right here at pi over 2 and this mark right here, which is at 3/4 pi. So you knew it had to be something that's between pi over 2 and 3/4 pi. So if you think about that, if you've got pi over 2 and 3 pi over 4, or 3/4 pi, in decimal form, this is 0.5 pi and this is 0.75 pi. So you know that the fraction has to be somewhere between that. So I looked at it, and based on dividing the pieces of pi out, it looked to me like it was 2/3 pi, which would be about 0.67 pi. But I had some people in earlier classes put 5/8 pi, which would also work. So really, if you have any value that is going to fall between these two items, it would be accepted for the period because that's how long it is. Somewhere bigger than pi over 2, but less than 3 pi over 4. All right, so let's go back to the graph then. So if that's the period, then it also asked for the amplitude. We wrote none because remember, tangent graphs do not have an amplitude because they don't have a determined height. They go on forever. So just looking at one more of those in that section, number 3, right here, same type. So yes, it's periodic. Its values are repeating. The heights of the hills and valleys are the same, so they repeat at regular intervals. The period, so you're looking from mark to mark here. You could either go from this mark to this mark and see 4, or you could also count. I counted from the top of this hill to the top of this hill. So you count over 1, 2, 3, 4 units. So that means the period is 4. That's how long it takes to make one full cycle. Remember that the amplitude is half of the total height. This goes from -1 to 5. So it's 6 units tall. Half of that is 3. So the equation of the midline, remember, it must have the y equals because that's what makes it a line. It's the line y equals 2 right here. All right, so those were the first types of problems that were in the review. Second type of problems were some graphs. So there was 9 and 11 were the sine graphs that were not shifted yet. So I'm just going to do number 11 from that. So number 11, the equation was y equals 5/2 sine of 2/5 x. So here again, our general sine function is a sine b x minus h plus k. These were before we learned the h and the k, so their h is 0 and so is k. So there are no shifts here. So the a value is 5/2, which means that's the amplitude. The b value is 2/5. Now remember, the period is 2 pi divided by b. So divided by 2/5. So that means 2 pi times the reciprocal, which would be 5/2. So if we do that, those cancel, and we find that the period, excuse me, is 5 pi. So now I need to graph it, which means I need to label my x-axis and y-axis. So if the period is 5 pi, that gets my last mark, my fourth one. Half of that is my middle mark, so just divide it by 2. That doesn't reduce, so leave it like that. Then you need your quarter marks. So same thing on the other side, negative 5 pi, negative 5 pi over 2, and then the half marks. Amplitude is 5/2, which is 2.5, so if I count by ones, that should work. All right, so now I'm ready to start graphing. Sine curves, you should know the shape. Looks like this. So midline, maximum, midline, minimum, midline. So we need to do that same shape here. Starts at the midline, then up to the maximum. The maximum is going to be 2.5 units away, so right here. Then midline, then minimum, also 2.5 units from the midline, and then back to the midline. Other side should be minimum, midline, maximum, midline. And so then connect the dots. Make sure it's curvy and not pointy. And there is our graph. Next ones asked you to write the equations. Sorry. So if you look at this graph, and number 13 asked you to write the equation. In number 12, you looked at this and hopefully determined that this was one full cycle from here to here. So the period was 4 pi. The amplitude goes from the midline, which is 0, to 2. So amplitude of 2, period of 4. So when you go to write that equation then, in number 13, amp is 2. You know 2 pi divided by b has to equal 4 pi. So if you solve this for b equals 2 pi divided by 4 pi, which is 1/2. The pi's cancel and the 2/4 reduce. So then all I did was plug in this for a and this for b. So y equals 2 sine 1/2 x, or x/2. x/2 and 1/2 x are the same thing. All right, next you had some cosine graphs. So I'm going to look at number 19, which was y equals 3/2 cosine of 1/3 x. So much like I did in number 11, I see here that my a value is 3/2, which is my amplitude. My b value is 1/3, so that means 2 pi divided by 1/3 equals the period. So that's 2 pi times 3, which is 6 pi. So my period is 6 pi. That means that now I can draw my graph. So fourth mark gets 6 pi, half mark gets 3 pi, then you need the quarter marks. So negative 6 pi here, negative 3 pi here, and the quarter marks. Amplitude is 1.5, so 2 marks should be plenty if we're counting by ones. And then, again, knowing the parent pattern. For cosine, it's maximum, midline, minimum, midline, maximum. So this pattern is what I have to draw. So starting at the max, which is 3/2 away from my midline, then back to the midline, then 1.5 units to the min, then midline, then back to maximum. On the other side, down to the midline, then minimum. Oops, I didn't get that quite low enough. Midline, maximum. And connect your dots. All right. Next one, looking at a tangent graph. And we'll look at number 29 here. Had the equation y equals 2 tangent 1/4 x. Remember that 2 isn't an amplitude, but we discussed in class that that doesn't mean that the a value doesn't have meaning. This is still a vertical stretch by a factor of 2, which means that it's going to be twice as thin or approach the asymptote twice as fast as the parent graph does. Now, when we are labeling our actual period, we only need this. And remember that for tangent, it's pi divided by b, not 2 pi divided by b. So if I do pi divided by 1/4, that's pi times 4/1, which is 4 pi. So when I go to draw my tangent graph here, remember tangent graphs, you only need 2 marks on each side. So this is 4 pi. That means this one is 2 pi. On the other side, negative 2 pi and negative 4 pi. Now, tangent graphs start on the midline, and they have a dot, then an asymptote, then a dot, asymptote, dot. Now, this A comes into play by making it thinner. So normally at the halfway point, remember we made our parent graph at the halfway, its value was 1. Because this has a vertical stretch, its value at the halfway is 2. So you can see how much thinner that makes the graph. Same thing in this direction. At the halfway mark, it's 2, so it's thinner. So down here, thin branch, and thin branch here. And there we have our graph. It asked us, excuse me, for the period, which we've already listed. It also asked us for the zeros. So remember, the zeros are going to be wherever the first one is, which is at 0, plus whatever the period is, k. So in this case, the period is 4 pi, so they're going to be 4 pi k, 0. Then the asymptotes, the first one is at 2 pi, and then they repeat every 4 pi. So 2 pi plus 4 pi k. All right. So that covers one of each of the original types of graphs that we did. Now we're going to look at some shifted graphs here, just one really, that has both the horizontal shift and the vertical shift. So we already covered how to change the period, how to change the amplitude. Now we're going to look at making sure that we know how to do the horizontal and the vertical shift. So I'm going to look at number 41 for that, which is y equals sine of x minus pi over 2 minus 2. So on this, obviously the amplitude is 1 because that hasn't changed. There's nothing in front. The period, there is no b to multiply times the x. Remember that b values are always multiplied with the x. H values are added or subtracted. So since there is no b written, that means it's 1, so the period is 2 pi. My horizontal shift, since it's negative, it means it's right. So that's right pi over 2. And then my vertical shift is negative, so that's down 2. So when I go to graph it, I'm still going to label the same way that I would if this were not a shifted graph. So I take the period, and since it's a sine curve, I do 4 marks. So the period's 2 pi, so 2 pi, pi, and then my quarters. Then over on the other side, negative 2 pi, negative pi, and the quarters. Now, I have my period here. Again, the amplitude is 1, so I don't really need to change my scale a lot because even though I have a vertical shift, it's not that far. So, counting by ones here. Ooh, I got that way too close. Sorry. I wish I could erase, but I can't. So this is going to be a really, I'm just going to make them bigger and redo. There, 1, 2, 3. Can't really work in that small of a space. Okay, so first thing you do when you have a shifted graph is you start with the vertical shift, which is down 2. And you draw your new midline. All your dots are going to either be on that line or will go up or down from that line. So this is your new midline, down 2. Your horizontal shift is right pi over 2. Well, if the second mark is pi, that means the first mark is half a pi. So that means we're shifting 1 mark to the right. So these dashed lines indicate my shifts. So the place where they intersect is my new origin. So sine curves start on the midline. So that means they start right here at the intersection. So right here, midline. Next mark is going to get a maximum. Since the amplitude is 1, that's up 1 unit. Then back to the midline. Then down to the minimum. You don't keep adding spaces, you just continue in the other direction. So I'm done with the right side, so keep going over on this side. The next dot, since this was midline, should be minimum, then midline, maximum, midline, minimum. And there is our very pretty graph. All right, next group, we are looking again at the picture and trying to write the equation. So if we look here, at number 48, it says the parent graph is the dashed graph and the solid line is the new one, and we're supposed to describe the transformation. So if you look here, the midline has gone to y equals 2, so that's where we got vertical shift up 2. This is a cosine parent graph because it starts at the max. The max here is way over here, so that's how I got right shift pi, because the maximum has been moved to the right pi units. So horizontal shift, right pi. Then the amplitude of the new graph is 2, where the parent graph is 1. So that's a vertical stretch by a factor of 2. We made it twice as tall. Then the period, this is the one where you have to actually do a little bit of work. The period, if you look, of my new graph is 4 pi. So if I look at the period of 4 pi, that would mean that 2 pi divided by b had to equal 4 pi, which means that b, in order to get that period, would have to be 1/2. So that means that my b value was 1/2. You have to know b in order to describe the horizontal shrink or stretch. Remember that the horizontal is the tricky one, because when it's a fraction, it's a stretch. So it's a horizontal stretch, and remember that on the b values, you always have to do the reciprocal. So it's not horizontal stretch by a factor of 1/2, it's a horizontal stretch by a factor of 2, because 2 over 1 is the reciprocal. So once you have that, you can write the equation. We could see that the amplitude was 2. We saw from the dashed graph that the parent was cosine. We just calculated b to be 1/2. We said that it was a right shift, which means minus, and the value was pi. And we said the vertical shift went up 2. So that completes our equation. All right, last thing is to cover a little bit from, I didn't assign a lot from lesson 35 because a lot of the problems were unnecessarily difficult and not necessarily related to the embedded assessment. But these 4 that I'm about to go through do relate to the embedded assessment very strongly, in fact, just like lesson 35-1 that you went through in class. That is very strongly correlated to the embedded assessment. So when we look at lesson 35, and I assigned 1A and B. So I don't know why I switched back to that. I didn't need to look at a picture. But number 1, it gave you some information. It told you about the Ferris wheel. It had a diameter of 94 feet. It said the highest point was at 102 feet. And it says 1 rotation every 80 seconds. So if you draw a picture like we drew a picture in the lesson with the sky wheel, here's the Ferris wheel, here's its diameter. The diameter is 94. Excuse me, which means that the radius has to be 47. So this is 47, this is 47. It says that the highest point, or the maximum, is 102. So that means this whole thing is 102. So the only thing left to label is the distance down here from the ground to the bottom of the Ferris wheel. So we can get that by doing 102, the whole thing, and subtracting the 94 that's taken up by the wheel itself. So 102 minus 94 is 8. So this is 8 feet. So if we do that, we also know that it makes 1 rotation every 80 seconds, which means that's its period. So if the period equals 80 seconds, that means 80 equals 2 pi over b. So if you solve for b equals 2 pi divided by 80, which is pi over 40. So this is your value of b. Now, in lesson 35-1, we talked about the relationship of certain things and how important it was to understand them. If you understand those, you can write this very, very quickly, because we said that the radius is going to be the amplitude. So when we look at this, we can see that the radius is 47. So when I go to write my function, h of t, I know that the amplitude is going to be 47 because that's the radius. Excuse me. If I'm rotating the same way that we did in the sky wheel, starting here and rotating counterclockwise, that means I can use a sine function. So I'm going to make it a sine function. Then my b value I just solved for. It's pi over 40 times t. Remember that there is no horizontal shift here because the value starts at the midline, then goes max, then midline, then minimum. So there's no horizontal shift, so we can keep these together. Then remember the k value is going to be the value at the midline. Well, I already drew this over here to hint you the center of the wheel is going to be 8 plus 47, which is 55. So that's my value of k. That's my midline value. And also then is representing my vertical shift. So that is how I got that answer in A. Question B asked, according to the model that you wrote, what is the height of the car when the ride starts? Well, the way we wrote it, since we didn't write it with a horizontal shift, we were starting at point A. So starting it that way, that means that our starting height in part B would be 55 feet. All right, last one, number 3, I assigned A and B. It says that this function, f of x, equals 3.5 cosine of pi over 6x plus 3.7 models the height and feet of the tide at a specific location x hours after high tide. So here we're using a cosine curve. Tides are also something that is obviously a periodic phenomena, so we're using a cosine curve to describe it. So when we're looking at this, our midline here is going to be at 3.7. Our amplitude is 3.5. Pi over 6 is, of course, going to help us calculate our period. So question A asks, what is the height of the tide at low tide? Well, low tide, remember, if it's saying low, that means it's asking you what is the minimum. So remember that the minimum is the amplitude away from the midline. So here our midline minus our amplitude gives us our minimum. So here our midline is 3.7, subtract our amplitude, which is 3.5, which means that the height of the tide at low tide, the minimum value, is going to be 0.2 feet. So that's how I got that answer. And then B asked, what is the period of the function, and what does this tell you about the tides at this location? So this is a cosine curve, so 2 pi divided by B gives us the period. So 2 pi divided by pi over 6, which means 2 pi times 6 over pi. I'm going to go ahead and put this one with a 1 in the denominator to help see that the pi's cancel. So 2 times 6 then is 12. So the period is 12. We were measuring time in hours because it said X hours. So 12 hours is the period. What does this mean? This means that it takes 12 hours to get from one low tide to the next low tide, or it takes 12 hours to get from one high tide to the next high tide at that specific location. All right, did really a lot of those for you, so hopefully you feel prepared for your embedded assessment and for your quiz. Happy studying!